Welcome to the Road to Accountable AI. I'm Kevin Werbach, Professor of Legal Studies and Business Ethics at the Wharton School of the University of Pennsylvania. For decades, I've studied emerging technologies from broadband to blockchain. Today, artificial intelligence promises to transform our world. But AI won't reach its potential without accountability, mechanisms to ensure it's deployed in responsible, safe, and trustworthy ways. On this podcast, I speak with the experts leading the charge for accountable AI. If AI is going to be accountable, then we need to understand what the AI is doing. That is the area of AI explainability. I speak with Krishna Gade, founder and CEO of Fiddler, one of the leading companies in the AI explainability space. We talk about how it's possible to provide useful explanations about machine learning systems, what changes in the generative AI case, and going forward, how it's possible for explanations to keep up with the increasing complexity of AI systems. We also talk about how explainability means different things in different contexts, how organizations need to think about what's necessary in terms of explainability, how regulation relates to the need for explainability, and how explainability fits into the larger paradigm of AI observability. I hope you'll enjoy my conversation with Krishna Gade. Krishna, welcome.
Hey, Kevin. Thanks for having me on the podcast.
Why is it important to be able to explain the outputs of AI systems?
It's a great question. I think it probably comes from the human desire to build trust, and I think the way we have scaled as a species seems like we are able to propagate trust better than any other organism on the planet, and we work better in abstractions. You can have 1 billion people in a country ruled by one single individual. You can have 100,000 people go to a football stadium, watch a soccer game, and come back peacefully because there is implicit trust even with strangers, right? And I think a lot of that germinates from the fact that we sort of like understand enough about each other to trust each other at different levels, professional life, personal life, general day-to-day life, right? And so when it comes to machines,
so how does explanation promote trust? I know you worked at Meta or Facebook, right, developing explanations for things like, why did I see a certain ad? So how does that promote trust if I know the certain factor that was involved?
It's the same. That's right. It's the same as I was saying, right? Essentially, like, how do we trust another individual when we know what they're doing, why they're doing, when we try to understand where they're coming from, we develop trust with the person, right? Imagine someone who's like complete black box where we cannot read that person. And they're making critical decisions for us, or, would we trust them? It's very hard for humans to be able to relate to them and trust them, right? So I think it comes from that, right? So if a machine is making decisions in the black box and we cannot really find out why that is doing what it is doing, and we cannot develop intuition in terms of how it's working, it's pretty hard, right? Even think about like regular machines that we use in our day-to-day life, like we kind of reason about a machine, how that works by trying and failing and trying and failing, and try to develop a mental model. How does a washing machine work? How does a microwave oven work, right? How does a coffee maker work? Now, same thing with the computer, where like an AI system could be making maybe a decision in terms of like, you're going to be accepted for this loan, or this is how it's going to be a mortgage rate for you, or your resume was selected for the screening process, or this is the clinical diagnosis based on the conditions that you have. How do you take those things at face value? It's pretty hard for humans to trust that machine at that point, and you have different questions. Is it working fairly for me? Is it discriminating? What kind of factors did it look at? All of those things come to question, and I think that's where explainability of machine learning and AI models becomes very important, because it fills that gap. Is it explaining everything? No, it's not, right? Just like a human can never explain everything in terms of how they do what they do in terms of their actions. It's pretty hard to explain the entirety of a very complex AI model. But the more you can actually ask questions, the more you can interrogate it, the more you can get answers from it, the more human intuition you can develop around it.
So what kind of explanation then can you actually provide with Fiddler?
So Fiddler basically takes the approach of treating the model like a black box and asking counterfactual questions towards it, right? So we believe that the whole explainability problem is also a human computer interaction problem, not necessarily just a technical, understanding the neural network type of a problem, right? So that's why we've developed technologies that can probe the models behind the scenes, ask with different counterfactual questions, basically probing different line of questioning. Let's say, if a customer applies for a loan, and there are 3-4 factors in their loan application. Let's say their current salary, their previous debt, and the occupation that they're in. And based on that, let's say the AI model is making a credit risk decision. Now, what Fiddler tries to do is basically tries to probe with these factors by slightly perturbing each of these factors, increasing their salary a little bit, decreasing it a little bit, increasing the previous debt and whatnot, and then trying to see how the model reacts to that changed scenario or a counterfactual scenario. And based on that, it derives that the importance of each of these variables, we call them features in the machine learning world, and so importance of each of these features to the model's decision. And that tells me, okay, if I'm getting a low credit risk score or a high credit risk score, what are the different factors that are contributing to it? Is my salary not good enough, or is it like my previous debt too high? So those, or what's my relationship with occupation on the type of loan that I'm applying? All of those things can be made available.
How do you determine what counterfactuals to ask? Because I would think, for example, in the loan example, you could do a series of counterfactuals about income, and it might show that it's sensitive to income. But if you don't ask about race, then you don't know whether that's a factor.
Correct. So I think that's a great question, right? So first of all, from a computational perspective, you run into exponential complexity, right? So you have too many things to ask. Your salary can be $0 to like whatever, $1 million, right? So there are obviously things that don't matter, right? So what you try to pick for is like the range of questions that make sense for that individual, let's say in inference in this case, individual loan application. So what Fiddler tries to do is we call it the reference baseline. So it basically plucks the counterfactuals from a reference baseline, and the reference baseline comes from typically the data that was being used to train the model. So you're kind of like trying to look at, okay, I'm trying to build a credit scoring model, and I have like a set of loan applications that have people applied to my bank in the past few years. I know which loans were granted, which ones were denied, so I have like the ground truth. So now from that training data, I've curated that training data, I'm building the model, right? So that becomes the reference set for us as well, for Fiddler as well. So when basically we try to take like a counterfactual, we're not drawing it from the vacuum, we're trying to sort of pick from a reference set. So of course, the explanations are dependent on the reference set. So this is what we call contrastive explanation. So Fiddler's Shapley explanation algorithm actually depends upon the reference set. So you can actually choose different reference sets. So you can ask a contrastive explanation saying that, okay, compared to people like, I'm a software engineer in San Francisco, compared to other software engineers that are living in the similar zip code, how is my explanation in terms of a loan acceptance or loan denial? So you can actually do that type of contrastive analysis. So it's heavily inspired by the Kahneman-Miller's norm theory. We call them these norms. So you can have different reference norms that you can compare a single point that you're explaining and get explanations that you can try to then look at all the 360-degree view of why the model might be deciding the way it is deciding.
How precise can the explanation be?
See, I think this is a good question, right? So of course, the explanations, we are basically constructing like a game theoretic formulation to do this, right? So it goes back to the axiomatic axioms that stand behind these algorithms. So it turns out like the algorithms that most people are using to explain machine learning models come from this person, Lloyd Shapley, who invented this Shapley value in the 1950s. And he was trying to solve this cooperative game theory where, the problem was the following. Imagine 3 people come together to start a business, and the business starts making profits or revenues. Now you want to do a fair and appropriate allocation of who's going to get how much profit out of this business, right? So how do you do that? So he constructed this game theoretic formulation where in a simulation where person A joins the business first and the business makes $100 in revenue versus business B joining first and then business makes $50 versus C. So you can construct these various game theoretic formulations and all the combinations. And he came up with this axiomatic kind of theorem called like Shapley value, which he proved out, where he said like if you take the marginal contribution of each of these individuals across all those possible combinations, he called it the Shapley value, which is he's called it that is basically the fair and appropriate value that you can assign to that person, right? And he said basically that this Shapley value holds like several different things. It's basically very symmetric in the sense that if you sort of if a if a person has like if two people have same contribution, then they get the same Shapley value. If someone is not having a contribution, they will get a zero Shapley value. So it basically follows like some of these axioms that hold true. Now that is how all of the explainability algorithms are they're sort of held upon that axiomatic principles, right? Because otherwise it's harder to prove them out without having a human verification that is this explanation good enough for you or not, right? And that changes from scenario to scenario. So most of the explainable AI field stands upon these the shoulders of the Shapley algorithm. There are various other variants of it. There's common Shapley value that people use for debugging deep learning models and other types of models.
And does anything change as we move from predictive models and supervised learning to generative AI?
Of course, a lot of things change, right? So now, with the case of generative AI, you're not coming. First of all, the model is not generating one single prediction or a set of predictions. It's actually it's generating a piece of content, and the piece of content also it's I mean, in some ways it's predicting the next word, but then the next word is dependent on the word that already previously predicted. But then it's sort of like it's a pretty complex mechanism that's working underneath. So explaining generative AI through this means is interesting. It's also kind of like the questions are like slightly different in the case of generative AI, right? So the questions are more like, okay, are you like the key questions people ask is like, okay, you're generating me this content. How did you generate this content? Most people are interested in where did you come up with this content, right? Because it's kind of like this, right? So if I'm asking you an interview question or you're asking me an interview question, if I'm trying to say some BS, if you cannot like really figure out where I'm talking from, or you don't have prior knowledge, or you at least cannot mentally map it to something that you already know, it's very hard for you to believe me what I'm saying, right? And so people want to be able to have like this sort of attribution in terms of what documents it's actually providing this content from. So one way to formulate explainability in generative AI is to think about, instead of feature impact, more of a document impact, right? Especially in a RAG like setting where people are saying that, okay, I would scope my generative AI model only to these documents that I am, it could be my set of policy documents if I'm in the customer support, or it could be my internal wiki pages if I'm building a search engine for my company. And so in such a scenario, what I'm most interested in is how did you get that response? Which document has contributed to that response, and how much did it contribute? So you can construct a similar type of a game theoretic formulation there, where you can say out of like 10 or 100 documents that the model is looking at, you can try to figure out the impact of each of these documents by using the similar mechanism that we talked about for feature impact. And so that's something that we are exploring. Of course, there's the other notion of white box explainability, where people want to go deep into the neural network and expose the neurological pathway and what is happening at each layer of the neural network as the inference is being made. That's interesting, but we have not seen many practical applications towards that until now. So.
Yeah, and I was going to ask you about that at the beginning. It would seem like intuitively the best way to write an explanation is to know everything about the internals of the model and build up from there. So yeah. I'm curious why you focused on the black box approach.
See, I think, so if you think about where does the whole notion of explainability in machine learning comes from, is it actually comes from financial services industry, right? A lot of the, so if you think about like in the financial services, there is this, previously they used to build a lot of these statistical models. They would still build these statistical models. So, being able to explain the model in a closed form manner, right? So where you can write down the equation or the formula and break it down and actually be able to reproduce it. It's very important from a risk management perspective, right? And they've been doing this for years on. And now, I mean, the sort of the desire is, can you do this for neural networks? Can you actually, take the whole sort of deep neural network and decompose it into some sort of a closed form, equation? And that's actually hard to do, right? How do you come up with like something as simple as that, right? So I think that's where the rise of black box explainability, because so so people call the other one interpretability. So interpretability is being able to, like, if I can write down it and break it down into constituent parts that I actually see it. So the explainability is more around, can I explain it to a human? Can I build trust with it? So people have developed different types of techniques, and one is the Shapley value technique. The other one is like being able to know the relationships between the inputs and outputs. So if I can, so a lot of the times what you want to be able to know is, even in the classical machine learning world, a regulator might want to know if a customer is paying the sort of interest on time. Is their credit score, is the model actually keeping their credit score flat or upright? you know they want to also make sure that the model is capturing the relationships in an appropriate manner. So if like you have a non-linear model and if the explanations are not rational, then that won't pass the regulator sniff test. So you have these partial dependency plots, conditional ice plots, and all of these different ways that expose the model. Even if it's like a model that you cannot write down as an equation, you can sort of like expose that this is the relation between the inputs and outputs under these conditions. That would still that has still been accepted in the industry as a passable explanation, right? Now, could you do that with more and more complex models? That's been the journey of explainable AI. Could you do that at very complex deep learning models? Let's say computer vision model that's detecting objects, sent a language model now with generative AI. So that is where the whole sort of the need for explainability to sort of explain these complex models is coming from, and people are developing various different techniques here. But the more the complex the model is, the harder it becomes to make it interpretable, the harder it becomes more to make it explainable.
So, is a financial services company that's had to deal with model risk management or those other kinds of compliance requirements, are they better situated to understand what's necessary for explainability, for trust as we get to deep learning and generative models, or is it companies that are not necessarily stuck in having dealt with these simpler models?
See, I think if you think about all the regulations that are being drafted by various different continents, most of them are taking inspirations from existing regulations, right? So if you look at like the Biden's executive order, it talks about model monitoring, monitoring drift, deterioration of models. EU AI Act talks about explainability and bias detection in models. And so these things have already existed in financial services. They have this thing called SR 11.7, which is a model risk management guideline document, which talks about explainability of models. And they've been existing from 2008 also, after the whole financial debacle, right? So a lot of the inspiration to model governance work that the rest of the industry is adopting comes from the FSIs, to be honest, right? And so now when people talk about explainability, they're not just talking about FSIs, although they are the ones that have a lot more strict regulations or some processes to get there. When now you have healthcare companies, pharma companies, you have like a lot of other HR companies that are basically trying to like get to that, right? So the question is like, what level of explainability is good enough? That also depends on the consumer of explanations. So what we have found out is explanations that are important for a developer that is debugging or testing a model are different from explanations that a regulator might need to approve of a model, or explanations that a business person might need to consume a model output, or explanations that some sort of a business leader might need to, that wants to know the higher level picture of the models, right? So explainability itself differs from the person to person, the user, right? So it's this almost sort of a a vague concept, to be honest. In terms, so you make your own definition of explainability. But I think more or less what we have solved at Fiddler is we have taken an opinionated approach that here is what a developer would need to test their models. Here, like for example, if I can look at like feature importance and compare it between training and test time, or if I'm looking at feature importance at different segments of data, where I can see if my features are being stable across all segments of data. If my, let's say, if my feature importance are not vastly changing, across different segments of data, how is my feature importance doing between production time and development time, right? All of those things help me to ensure that my model is performing the same way and it's stable. From a compliance perspective, or it could be different, right? It could be that I want to know a few examples of why did you deny this loan? What are the other similar users that were denied for this loan? Show me how the model is doing on different protected segments. Show me the variables that are impacting the denial of these loan applicants for this particular protected group. Right, so I might want to poke holes into things. I want to have a report that I want to consume, so that I can actually, as a regulator or the compliance person, I can bless this model. This is good enough, right? A business user might be different. So let's say I'm like on a customer support team and I'm trying to get the customer not churn from my company. I'm using this churn prediction model, and it's telling me this customer is likely to churn with 90%. Now what I want to know is what are the factors that are making them churn, and how can I intervene? Can I intervene? Can I give them some more discount? Can I add them one more product from our portfolio to their basket? What is it that is needed? Is our service not good enough? So I can actually, what is it that is important, right? So all of these, so we at Fiddler, we built a product that can solve for multiple of these personas. And that's what sort of we've been sort of found that this the north star for explainability is to solve for these things. So you're trying to build trust within the organization. You're trying to make everyone comfortable with the transparency.
Do you have to help your customers understand what questions they should be asking?
So we have made it easier for them to ask these questions. So like we have created this interface, we call it fiddling with the model. So hence the name Fiddler. So you can actually ask a lot of these counterfactual questions, because a lot of the times people want to dial up and down. People want to probe the model and see like, okay, if this person has, three more products in their product portfolio, would they be churning the same likelihood? Or, if they are coming from a different protected segment, would they be getting the same credit score? So I think those are the ways that they can help them build that transparency. So they've kept the we've kept the so the interfaces they're there for everybody. Some interfaces maybe more technical for developers to use. Some interfaces are a little bit less technical that like a compliance or a business person could use. Yeah.
You've been talking more recently about observability.
Right.
How is observability different from explainability?
Yeah. So when explainability talks about being able to understand the model at a micro and macro level, it does not really talk about the continuous monitoring aspect of it, because like one of the things that models suffer from, apart from being a black box, is they're also these stochastic entities, right? So we on the software side, we're used to writing code and seeing it stand the test of time, right? Example, I used to work as a software engineer at Twitter. I built some services in Twitter search engine. Some of this might still be running there, right? Like years.
I thought they tore it all out when Elon came in.
Of course, that's yeah. So yeah, of course, it's probably has happened. But I think the thing is software. Of course, software gets rewritten all the time. But the fact of the matter is that you have this sort of deterministic aspect of software, right? But when it comes to models, because they are highly dependent on the data that they were trained with, their shelf life is not very long, right? And so they're sort of, if the data changes, something else happens in the world. For example, a lot of supply chain models suddenly became inaccurate when COVID hit, because all the inventory management of like stores and everything vanished, right? So people suddenly started seeing, a lot of people were shopping for like sort of toilet paper and things like that, right? And then when interest rates go up, you see like unemployment go up, you see that affects like that affects your other pricing models, your credit scoring models, right? So there are a lot of external factors that determine more like this sort of model drift. People call it like this sort of like change in accuracy of the models, right? It could also be your own internal infrastructure, because models are so highly data dependent. Data pipelines are the ones that are feeding these models with the feature data, right? You have like these, you're collecting the data from various different sources and feeding them to the models for their inferencing, for their training time. If those data pipelines are broken for various different issues, system errors or other human errors, bad data can be fed to the model by accident, and that would also cause model performance degradation. So this model performance degradation warrants monitoring of models by necessity, right? Essentially, if you don't monitor the models, then there's no guarantee, all bets are off. Like there's no guarantee that the model that you train with 85% accuracy, 90% accuracy is going to run the same way. So that notion of monitoring of those models, now is like a fancy term for this is this observability, which is essentially derived from the software engineering world, where you observe these databases and applications for like errors and performance issues. You're trying to bring that again to the models, right? But one of the aspects of observability where explainability and observability meet is when you're trying to debug, right? So let's say if I'm trying to debug a model performance, let's say I know the model is having some issues, I got an alert, it's having a drift. If I can know which features are actually having, which data elements that the model is consuming is having the most impact, or which data elements are contributing to the data drift the most, then it helps me a lot as a developer to sort of dig into the problem very quickly and isolate it very, very, very fast. So that root cause analysis powered by explainability can be very important for observability, and that's what Fiddler combines those two things very nicely.
Mm-hmm. So ultimately, is observability a distinct function from model governance or ML ops or bias detection, or do all of these things ultimately come together?
So it's all kind of the same thing, right? So it's kind of which level of view that you're looking at. So from a purely operational perspective, we just talked about models. I'm a ML engineer. I created a model. I deployed it. A month later, is it going to perform the same way? I don't know. So that's why I need monitoring, right? And I'm an ML engineer. I want to debug what's my model is going on. I want to test it properly. Or someone is asking me to constantly, explain it, or like, give some examples how it runs and whatnot. So that's where I need explainability, right? So I need like, but then this aspect of I'm not working on one model, but I'm working on, my organization is building tens of models, hundreds of models, thousands of models, and there's no single place to track it. And there's no single place to keep all the reports around it, keep all the metrics around it, keep all the artifacts around it. That's where governance comes in, right? You're trying to create a process to control this. You just don't want to have, all kinds of models. You don't want to have team members building whatever tool that they are using to build their models running amok, right? Then you won't be able to control the output of it, the outcome of it. You won't be able to control the risks that the models, if a model goes wrong. So governance comes into it. And then a particular aspect of model performance. If a model is underperforming on a protected segment, that let's say you're an HR company, or if you're a company, let's say you're a hospitality company, if you're not, if your algorithms are biased against certain protected groups, then if your company might be in trouble because of some sort of a PR issue or litigation, right? So all of these are looking at model performance from various different angles. But the cornerstone we believe is AI observability. And this is kind of the way we define AI observability, is that by being able to monitor, explain these models, by being able to report out about the models, by being able to track the inventory of these models, you can actually achieve governance. You can make sure that you have controls in terms of fairness, and you can make sure your operational performance is there, and you have ability to root cause issues and build better models for your company. So that's kind of how we define AI observability.
I would assume in some ways the proliferation of AI regulation is a good thing for you, because companies are having these problems they need to address for compliance. But on the other hand, there's now all these different requirements. Some of them are vague, and now we're in the legal realm.
Yeah.
Does that make it harder to provide solutions?
Yeah, so I think there's a carrot versus stick here, right? So essentially, the companies that identify that, hey, we don't want to be that other company that where they didn't monitor their models and they incurred like hundreds of millions of dollars of business risk, or they got into some sort of a reputation damage. They go ahead, they try to make sure that they put these sort of practices in place, right? Now, some of them could be laggards. They might say, okay, I don't want to do this until there's some regulation that's out there that makes me do it, right? So we are not like we're not. So I think regulations are important. I mean, we are dealing with the technology like here, in from AI, which is very new, and it's we don't and it's developing at a rapid pace, and you want to make sure that uh, you have some controls in place that you're not sort of you're not letting it take its own course, right? So while we're not sort of against innovation. So it's sort of a we want people to build AI. We think AI has a lot of benefits, and I've worked in companies that I've worked at Bing, Twitter, Pinterest. I've been working on machine learning and AI for a long time. I've seen like amazing benefits that it can add to your business. But we think that it has to be done in a responsible manner, a trustworthy manner, and whether regulations exist or not, I think AI observability, explainability, these things will help you build that trustworthy AI application.
What's the hardest challenge that you're facing right now, at least from a technical standpoint? I know you've got a lot of challenges scaling up the business.
Yeah. I think from technical standpoint, we already talked about, as model complexity rises, being able to monitor and make sense of these models is an ongoing problem for us, right? Like we solve the problem at machine learning level, and then deep learning models, and then different types of deep learning models, and then there's large language models. So now we're trying to solve the problem for large language models, and even those models are becoming more complex. Now people are talking agents and multi-model workflows, and so the complexity of models keeps increasing. So that's one technical side. On the business side, I feel like the biggest challenge for us is like just this aspect of educating the customers, right? So essentially, it's still like an electric car right now. Is people feel like, okay, let me have it, when I need it, type of thing, right? It's not like a hair on fire type of problem for many customers. But it is indeed. If you look at them, a lot of these customers are just like sitting on like a ticking time bomb, right? If we speak to customers that have like, oh, we're running 100 models in production, we ask them, do you have any monitoring for their models? It's like, no. Or they do it like once in a while, manual checks, right? So a lot of people don't realize the gravity of the situation, right? And now with the rise of generative AI, they're dealing with even more complex models. So I think so a lot of the business challenges, being able to educate the customers, being able to let them know the challenges here, and then so there's that, and part of the reason why I do these podcasts is also towards that, right?
So on the first point, the technical point with the increasing complexity of models, I assume that you're optimistic that this is an arms race, that at least the explainability side can hold its own. But what gives you that confidence?
See, I think the things that we have developed are model agnostic, right? So we have tried to stay very we've done a few things which have helped us in the long run. So one is staying model agnostic, staying cloud agnostic, right? Staying this sort of neutral Switzerland for AI type of player, where we have customers that leverage Fiddler in combination with Google Cloud, Azure AI, open source, and Amazon. So and because of the way that we built the product, that only mostly relies on the inputs and outputs you're feeding to the model to give you a lot more insights. We can actually with very loose integration, we can provide a lot more insights and understanding about the model. And so with the large language models, the good part about it is it's the inputs and outputs are unstructured, so you can sort of like consume them quite easily, and in some ways, like for structured models we have to build a lot of infrastructure for data ingestion and whatnot. For unstructured, it seems quite easy. And then now this notion of being able to use being able to operate at the embeddings layer, is quite helpful. So one of the things that we have done for unstructured ML models, like deep learning models, was we convert the images or natural language into embeddings. And to track drift or to be able to understand the model, we deal in the embedding space, right? So you can cluster a bunch of embeddings as vectors on a 2D space, and you can group them as objects. You can color code them. These are good, these are bad, and you can kind of look at them, right? And that a lot of that work has benefited us to while we build LLM observability aspects of it, where we can consume these inputs and outputs. We can visualize them and say, okay, here are the prompts that are having hallucinatory behavior, or here are the prompts that are having PII issues, or here are the prompts that might be leaking toxic content to your users. And so you can actually go and figure it out yourself. And so that aspect of it has worked out well. So now we basically can fit in with any of these LLM providers quite easily. And even as customers move towards multi-model workflows and agentic workflows, this approach seems to work fine. Of course, there are nuances here. The metrics are not very hard to compute. What is a hallucination? What is PI? What is toxic? Is pretty hard to determine. So a lot of the work that we are building recently, we launched something called Fiddler Trust Service, which basically is a new approach that we've taken, which uses other language models to determine if a particular prompt and response are kind of in a malicious activity, right? So if the prompt has a jailbreaking activity, or if the response is not relevant to the prompt. I think this is a very new approach that we are working on, and that seems to give good results, because it's better than putting a lot of humans to go and label which response is hallucinatory, which response is toxic. So that's
so as the
basically
technology gets more complex, you can actually take advantage of it. Yeah.
Correct, exactly.
Absolutely. Well, fantastic. Krishna, this has been really fascinating, and I appreciate your spending the time going through it with me.
Awesome. Thank you so much, Kevin. Lots of great questions, and it was fun talking to you.
This has been The Road to Accountable AI. If you like what you're hearing, please give us a good review and check out my Substack for more insights on AI accountability. Thank you for listening. This is Kevin Werbach. If you want to go deeper on AI governance, trust, and responsibility with me and other distinguished faculty of the world's top business school, sign up for the next cohort of Wharton's Strategies for Accountable AI online executive education program, featuring live interaction with faculty, expert interviews, and custom-designed asynchronous content. Join fellow business leaders to learn valuable skills you can put to work in your organization. Visit execed.wharton.upenn.edu/ACAI for full details. I hope to see you there.